Hello everyone, this is the presentation of SmartGSN, which is a generative AI-powered online tool for the management of assurance cases. System assurance is a process that involves building convincing and valid arguments that a system is sufficiently safe, secure, or reliable to operate in a particular environment. System assurance is important in several application domains such as aviation, automotive, and healthcare to help prevent system failure. An assurance case can be used to support system assurance. Specifically, assurance cases are structured arguments with a supporting body of evidence that allow demonstrating that the non-functional requirements of a given system have been correctly implemented. The use of assurance cases is common across various domains since it allows preventing system failure. An assurance case can be represented using either textual notations or graphical notations as shown in Figure 2. An assurance case pattern is a reusable structure that eases the creation of assurance cases. System assurance activities include the creation of assurance cases and their maintenance. However, manually creating and maintaining assurance cases is tedious, error-prone, and time-consuming. Existing tools for managing assurance cases tend to lack natural language processing ability, rely heavily on model-driven engineering methods, and usually focus on a single aspect of assurance case management.
To address these challenges, we have developed SmartGSN, an online tool that incorporates the use of large language models to enhance the management of assurance cases. In these slides, you can see the features of SmartGSN, which includes the ability to create and edit assurance cases. It also facilitates the conversion of assurance cases from textual to graphical format. SmartGSN includes the automatic instantiation of assurance cases from patterns. Users can provide an assurance case pattern along with context information, one-shot example, or domain information to generate an assurance case. Our tool also features pattern detection with assurance cases. Users can supply both a pattern and an assurance case, and SmartGSN would accurately identify if the pattern has been utilized in the assurance case creation.
We will now focus briefly on showcasing the tool. Once you access your account, the Assurance Case Creator screen will be displayed. This is the first feature of our tool. Here you can import a previously made assurance case or create a new one from scratch, either dragging and dropping a desired node or simply writing it on the text editor box. As you can see, all changes made at both ends will update the information on the whole screen. Once you're done creating an assurance case, you can export it into a JSON file or an image file. Next, we have the pattern instantiation screen. Here, a request will be sent to the OpenAI API and get a reply with all the information needed. First, more context and information for the tool will generate better results. Then we need a system prompt and a domain information. The system prompt is already coded into the tool, so you don't have to explain the rules of GSN or any other context regarding assurance cases. The domain info is where you can provide context of a certain system in case you need to do so. The last thing we need is the LLM customization tab, where we can choose which LLM will receive the request and reply, the temperature of that LLM, and the maximum number of tokens the LLM can produce in the reply. Once we have everything, we can click the send button and wait for the LLM reply with our pattern instantiation. Once we get the reply, you can modify the assistant prompt to organize the information to match the required formats of the assurance cases to be read by our tool and generate the graphical format of the given assurance case. Finally, we have the detection pattern screen, which is very similar to the pattern instantiation screen. But here, the user prompt must have an assurance case pattern and an assurance case, since these two will be the ones compared to detect a pattern. Both texts must be delimited by a label. This is necessary for the tool to detect both, starting always with the assurance case pattern. And provide the similarity metrics. These are the ones you want the system to be based on. This means that depending on the metric value you selected, the system will consider if a pattern is detected or not. When you click the send button, the system will calculate the similarity metrics and will display if the pattern has been detected or not.